Hi folks, this is Jack in the training department, and today we're going to start a new series of videos that I want to make called Teardown Tuesday. And the goal in this series is to take apart a component every Tuesday going through 2022. So every week we'll tear apart a different component that's related to kitchen equipment. And the way this came about is I was thinking back to when I was a field technician, and I used to finish a repair and take the parts I'd removed back to my truck, and I would take those apart and see how they failed and why. And in the process of doing that, I learned a lot about how these parts work. And I think it'll be really beneficial to everyone if I take these things apart, but record it and show it to you so that all the technicians out there can see how these parts fail, but also how they're supposed to work in the first place. And I'll point things out along the way that I've learned just to give you an idea of how the parts work and ways that they fail. So the first episode here is a really common part in commercial kitchens. So I've got my teardown tray here, my dissection tray, and this part is what's called a BJ thermostat, or a BJ style thermostat, made by Robertshaw, or originally made by Robertshaw. And you can see on the back here there's a BJ in the casting, but also in the label for the part itself. It talks about what the model is. So this particular thermostat is new and uninstalled. You can see it's still coiled up here, but it was damaged in shipping and returned. Somehow it ended up back at our training center for us to use as an example. But you can see from the coil on here and the clean threads that this particular thermostat has never been installed. So let's talk first about how it's supposed to work. The gas inlet is here, and there's a little adapter plate that bolts on with a gasket, and the gas flows into this opening. Now in this particular thermostat you can see it's turned off, but as we start to rotate that around and we get to the low position, you can see we've got an opening here so the gas can flow into this part of the thermostat. These thermostats result in a lot of service calls when they're newly installed, and that's one of two reasons. The first one is the calibration screw down here is not set correctly, and the second one is that the bypass is not set correctly. And in this particular thermostat you can see the bypass screw here has been cranked shut, and it's actually been cranked shut with enough force that the screw itself is damaged. The bypass allows some amount of gas to flow continuously out of the outlet regardless of the thermostat position, as long as it's turned past the off position. So anytime that gas is flowing into the opening, the bypass allows gas to flow through the body past the thermostatic control and out to the burner. And we do that to keep the burner lit at a minimum flame. Now most thermostats ship with that screw all the way closed, and you as a technician have to make that adjustment when you install it. Never assume the bypass is set. Chances are it's not set for the piece of equipment you're installing it on. So let's get into how this thing actually works. So we know right away we've got a capillary tube, we've got a bulb, so there will be some fluid inside this bulb, and as the burner heats it up it will expand and push back into the inside here. So we can guess already there will be some kind of bellows, some kind of spring system in there. So let's start by splitting this in half. So we've got the front part here, and then we've got the back part here, and there's 4 bolts. Alright, so we've got all 4 of those bolts out, so let's try and get this separated. You can see it kind of splits apart. So you can see there's 2 parts here. So this is the front part that has our calibration screw and our gas inlet. Then this back part, you can see there's a spring down inside there, and there's this plate and this shaft. And the shaft goes up into a T-slotted fitting that's up in there. It's kind of hard to see, but up in this part of the body there's a T-slot, and we'll get to that in a second. We'll tear that apart separately. So in this half of the body, we've got the path for gas flow going through this fitting into this part of the body. Then we've got this big plate, and this plate is mounted on a spring. And that plate is actually coming shut and sealing against this lip. So let's see how far apart we can get this thing. So we're turning this. So looking at the way this is put together, let's try taking this nut off. So there's some thread sealant or some sealant compound on there. And it looks like this either threads into the body or it's just sealed in. So let's try spinning it out of there with some pliers. Oh, there we go. So as you might expect, it's not recommended you ever do this to a part you intend to install because the chances of damaging it are very high. But in this case, we're just trying to learn how these things work. Alright, so now we've got a really good view of what that part of the mechanism looks like. So this back here, it looks like one piece, but it's actually two, and it's bonded together so it makes a bellows. And as the fluid in here heats up, it's expanding, and that makes this bellows grow. It doesn't grow a lot, but it puts more pressure on the spring system here. And it looks like as this T-handle is turned, as the T-handle is turned, it's threading in and out of this threaded portion inside here. So it's changing the amount of pressure on that spring as we turn this in and out. So there we've just turned it all the way apart. It looks like it's actually reverse threaded. So here's our spring. And then there's just a little spacer washer there. Set those off the side. And then this is our bellows and cap tube and bulb. So this is the part that's really easy to damage during installation. If this becomes kinked or crushed, this thermostat will not function correctly because you'll have changed the amount of pressure on this bellows. So now we've got this little brass plate on this threaded T-handle shaft. And then if we go back to our front part of the valve, we can put this back together, and you can see how that plate sits down inside there and closes off the gas flow. So that's pretty interesting. This is a little soft washer. Looks like maybe aluminum, real soft alloy of aluminum. So it's a crush washer, and it's got a little bit of grease on it. Set that off the side. And we talked about bypass. Now, the bypass screw, again remember, is right here. This is the bypass screw right here. And if we look at the inside of this housing, we can see there's an opening here and an opening here. So we're sealing against this lip when the valve's closed So it's literally bypassing around that sealed lip. It's letting gas flow from this part of the valve past into the back part of the body through this series of openings. So let's take that screw out and see what that looks like. So this one was all the way closed. I'm imagining this is probably going to look kind of like a part from a carburetor. Carburetors do this kind of passage system pretty frequently. Yeah, and it does. So taking a look at this, you can see it's a tapered seat valve. So as you back this out, as you unscrew it, that taper is going to let more and more gas flow past and into these bypass passages. So that's all that is. It's just a little screw with a tapered seat. So let's go ahead and take apart the front here and see how this part works. We've got some Loctite on one of the screws here, so we'll have to try and dig that out. So there's one. And the Loctite usually means that it's adjusted and sealed from the factory. They don't want you to open it, which is all the more reason that we should open it and see how it works. Alright, so there's the retainer, and then this mechanism is the actual calibration. So the first thing to notice right away is this is a tapered seat. So it's sealing on a precise taper. And they've used a lubricant or grease here. It's almost like a Teflon. It's kind of tacky. There's really a lot of it, probably too much. But that's what they're using to lubricate the inside of that valve. So as we look at this part, there are no more pieces in here we can take apart. This is all just a casting now. Nothing else left in there that we can mess with. Now in this, now you can see that T-slot down inside that this piece of the valve mechanism would slot into. So if you remember, we had this part threaded back here, and as we turned this, it's actually threading and unthreading this back in the back of the valve and changing the balance of the spring pressure against the bellows pressure. So let's take a look at how that calibration screw is set up in there. So looking at the way this goes together, looks like this spring is just on here to keep pressure against the valve seat, against the tapered part of the valve body, so it keeps it sealed. So let's just try and pop that off. Maybe it doesn't come off this way. It's held on against the tabs of the calibration screw, so we might have to take the calibration screw out first. Yeah, looks like we do. Alright, so the calibration screw is a really thin slotted screw, and it's got a dab of nail polish on it. And you'll see this in all different colors. Could be red, could be green, could be yellow, whatever the nail polishes they've got on the factory that day. And typically before you go to adjust this, you've got to get a little dab of nail polish remover in there to get it loosened up. Now, having this out of the valve, we may be able to get it without putting any nail polish remover on there. Yeah, see, it's really hard to turn. On purpose. Let's do this. Let's get a better grip on it. Yeah, so now we're getting some turn on it. Really had to get a good bite on it. So we're going to try and take it out going counterclockwise, which may or may not be the correct direction to get this apart. I've never taken one of these screw assemblies apart before. In fact, it actually looks like it's just spinning. Does not look like it's actually coming out at all. Ah, so if you look down inside, in fact, let me put it on like this because it might be easier to see. That T-slotted fixture down in there spins when we adjust that calibration. So that's all they're doing. So when you adjust the calibration, what you're actually doing is changing how far this seal plate is threaded into this bellows. So you see they get closer together and further apart as you thread them in and out of each other. So when you make an adjustment to that screw down inside there, really all you're doing is changing the precise position that this plate is in relation to this bellows. And what that means is what you're doing is changing this offset distance, but also changing the amount of spring pressure in here, because this spring is compressed by that threaded fitting. So it's going to have to fight that spring pressure even more with the bellows to close and shut off that gas flow. If this system fails, if this bellows fails, or this cap tube is kinked or compromised, or this bulb breaks off, because sometimes they'll break off back here, the thermostat's going to go into runaway. It's going to overheat because now there's no way to compensate against opening that valve. The bellows can't expand anymore. They've lost that fluid, that ability to open. So it looks like this particular assembly is not going to come back apart for us, or it's not going to come apart any further for us. So I think that's about as far apart as we can get it. I might be able to sneak that in there and hold it, but I think that's probably as far apart as we're going to get. Yeah. All right. Just real quick, when we look at the knob has these notches in it. It's like a castle notch. These notches snap down into this part of the valve. So the knob is actually turning this part of the valve. And you can see there's a dent in the shaft of the knob, and it's sliding onto this flat, and that's what actually turns it. So the knob engages onto this piece right here. Alright, so that's it. That's all that's in there. Pretty straightforward valve, really, and it's a design that's been around a long time, so it's not surprising that it's pretty well figured out as far as manufacturing and how it goes together. But that's how it works. Real simple. Just screws and springs and this little bellows system. Alright, well that's it for this one. The Robertshaw BJ style thermostat. So I will see you for the next one, next Tuesday. Thanks. Have a good day. Hi folks, my name is Jack Kell and I'm a Senior Technical Trainer for SmartCare. The video you've just watched is part of a larger series of technical training videos we make available to our technicians at SmartCare. If you found this interesting and you'd like to see more, please subscribe. I'll be releasing a new component teardown video every Tuesday in 2022. If you're already a SmartCare technician and you have a part that you'd like to see me tear down, please reach out to me internally for shipping instructions. If you're not a SmartCare technician, but you or someone you know would like to learn more about a career as a service technician specializing in commercial restaurant equipment, please check out our open positions at www.smartcaresolutions.com/careers. Thanks for watching.